This lesson is for FST, Lesson 1-2, Centers of Data and Weighted Averages. I am considering turning this lesson into a 2-day lesson in the future, but know that all the topics here are contained within the lesson. The measures of center are things that students are probably familiar with. They are the mean, the median, and the mode. Once in a while in the book, those may be referred to as the measures of central tendency, but for the most part the book uses the measures of center as their description. So as a group, they are ways that we can study the middle of data. The mean is also called an average, and is typically calculated as the sum of the numbers divided by the total number of numbers, typically represented with the letter or the variable n. The median is usually the middle number. It's important that students remember that when they're finding the middle number, the data has to be in order. So put the numbers in order before you start to attempt to find where the median is. And then the mode is simply the piece of data that occurs the most often or the most frequently. Keep in mind that it is possible for there to be no mode, or sometimes there are multiple modes. Yesterday, or in the last lesson, we had talked about the importance of reading the title when you're looking at tables. So here we have an example of a table of the weights of members of a wrestling team. The first column represents how many members are on the team, and then their respective weights in pounds. To determine how many members are on the team, you would simply want to add up the total number of members listed. We would simply add 4 plus 3 plus 3 plus 2 plus 1, and we'd end up with 14. To find the mean weight, we wouldn't simply add up these numbers and divide by 6, because remember there are 14 people on the team, so we'd want to make sure to divide by 14. So because there's 4 people that weigh 120 pounds, you'd either have to add 120 4 times, along with 135 3 times, or a more simple way to do that, or a faster way to do that, is simply to multiply 4 times 120, then add it to 3 times 135, and so on. So if you do that for the entire table and divide by 14, the mean weight should be 152.5. To find the median weight, we'd find the person that's in the middle. Since the numbers are pretty much in order already, we would simply want to find the middle of 14 things. When you have an even number of items and you're trying to find the middle, you simply divide by 2. 14 divided by 2 is 7, but because there's an even number, the 7th and the 8th numbers, or the 8th members of the team, would be considered the median. So we are going to count to the 7th and 8th numbers. The first 4 people that are the lowest weight on the team are 120, so that's 4. The next 3 would be 7, and then the 8th person would be here. So to find the median weight, we would add 135 plus 145, and then we would divide by 2. And when we're done there, we get 140. So far we have 2 measures of center that we are using to describe the members of the team and where the center is. But we would like to analyze now which one better describes the typical weight of the team. If you kind of look at the table here, kind of draw a line here and look at the 2 sets that divides the team into. 10 of the people are 145 pounds or less. There's only 3 people that are more than 145 pounds, and actually there's 3 that are more than 170. So the typical weight is more down in this range. So we'd want to pick the lower of the 2. So in this instance, the typical weight is actually represented better by the median. Know that when students are answering that type of question, there could be varying different reasons for why they would answer the mean or the median. And that's what students will practice in homework. While students are doing the homework, there are 2 types of ways of organizing the data that they're going to run into. One of them is a dot plot. A dot plot is simply a way of indicating the frequency of individual items using dots. It's very important that students, again, read all the labels. This is a picture of the answers given when students were asked the number of books in their backpack. So if we want to find how many students were asked, we would simply count the dots. Then if we count the dots, we find out that there are 10 students in the second hour. Then how many students have no books? This tends to be a tricky question for some kids. Most people give a correct answer of 4, because they simply look at the 0 and count how many dots are there. Sometimes a common wrong answer for this question would be 2. You're going to write that and cross it out. Sometimes people look at the 2 and realize that there's no dots and believe that that is the answer. But remember, we're looking at who said they had no books. These were the answers given. This is how many times those answers were given. So no books is represented by 0. We would count the number of people who gave that as their answer. Then how many kids have only 2 books in their backpack? We look at the 2, there are no dots above it, so we'd say none. None of the kids said I have 2 books in my backpack. They all said I have none, 1, 3, or 4. Another thing that students may run into in the homework for sets of data is a stem plot, also sometimes referred to as a stem and leaf plot. The numbers that are to the left of the vertical line are called the stems. The numbers to the right are called the leaves. If you put those numbers together as a 2-digit number, you'll have test scores. So the lowest score was a 44, the highest score was a 98, and then there's all these other options. Again, what's nice about this particular arrangement is that it shows the frequency of items individually. So again, how many kids took the test? To determine that, we would simply count the leaves. So if we count the leaves, we end up with 21. One of the things that the book has you do, which is not explained in the book, is to calculate the range of the items. So just a quick reminder for students that when you're finding the range, it's always the max minus the min, the highest number minus the lowest. So again, we reviewed that already. The maximum score here was 98, the lowest score was 44. And I'll leave students to figure that out on their own. The median would be the middle score. And so the middle score of 21 things would be the 11th score. So then we have to figure out which number that is. I would recommend in this instance counting or tallying from both the lowest and the highest points of the stem plot and working our way through to the middle. So usually I have kids do the mathematical number first, so figure out mathematically where the middle of 21 things is. It should be the 11th term, and then verify it by counting from either end. When you're starting with the lowest, you can just count left to right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we're thinking that probably the 84th score is the median. But now let's verify that by counting from the top end back. So if we start here, we want to make sure that we're going from right to left. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So indeed, the 84 is the median score. Another topic in the lesson is summation notation, also sometimes referred to as sigma notation. Whenever you're taking a sum of something, that simply means addition. So when students are learning summation notation, probably for the first time, they just need to remember simply that a summation question or a sigma question is simply another way to write addition. The sigma notation will have a brand new symbol. It's this funny looking E shape, and students will see a little bit more accurate depiction of that symbol when they look in their textbooks. The thing that's underneath the sigma symbol is where you start, and the thing that's on the top will usually be where you'll end. So it's going to tell you which numbers get added from the beginning to the end. The items that you're going to add together are usually labeled with some kind of a variable, and so this is telling you what to add. So if we were to actually apply this now to a specific problem, number 8 in the homework looks like this. So this would simply mean that students should add up the numbers of x from 1 to 27. So that means it would be the same as you taking a number, the first one, adding it to the second, adding it to the third, all the way down to adding it to the 27th number. So one of the benefits of doing a sigma problem is it very concisely and in a condensed version or fashion allows you to show how to add up 27 things without actually having to write out that entire process. Similarly for number 9, here they want you to add up the 4th number all the way up to the 8th. This one would look like this. Take the 4th number plus the 5th plus the 6th, the 7th, and the 8th. And so you'd simply, once you know those numbers, you'd add them together and then you'd be able to find a result. We don't have the numbers available in either of these questions, so we are not going to get a numerical answer, but just practicing here that the process means add up certain numbers, where to begin and where to end. Typically the sigma notation is used when working with averages or means. As soon as you take a sigma and either divide it by n or multiply it by 1 over n, now it has become an average or a mean. So it's just symbolically another way to show how to calculate a mean. Keep in mind that when you divide by something, that's the same as multiplying by its reciprocal. So to help students remember these two versions of n, think about it like a 2. If you divide by 2, that's the same as multiplying by a half. So the homework will have students practice further with sigma. Another topic in the lesson is weighted averages. There is no official formula for weighted averages, so this is kind of my version of how to do them. Students will want to add up the value that they're working with multiplied by its weight. Keep in mind that the multiplication should come before the addition. And then you always want to divide by the total weight. The weights on the top and the bottom need to match up, so make sure whatever weights you're using here match up with the numbers at the bottom here. Grades tend to be a good example for most kids to understand, so that's our example here. We're going to take Fred and look at his score. He got 89 on homework, and the percent of his grade that will be is 25%. So we're going to add that to his next score, 82 for quizzes, and that is 10% of his grade. Then we take 87, multiply by its percentage, and attendance times its. And so once we add and multiply all that together, next we need to figure out what we would divide by. And we would divide by the total weights. So the total weights here would be 100%, or in decimal form you would say by 1. So when we finish off Fred's score here, his score is 89.6. I'm going to have students take a moment right now to figure out Adam's score and to write out all of his work. So students, pause the video right now and go ahead and write that out and calculate it yourself. And you end up with 88.15 for Adam. And so then the question is, who got the better grade? Clearly, Fred got the better score. But if you look at the scores, Adam consistently scores in the 90 on the academic portions, where Fred only scores in the 80s. And so what this illustrates is, first of all, that attendance should not be considered part of a student's grade, because it doesn't accurately show what they've learned. And also, it shows that 20% of your grade does make a difference. Attendance alone boosted Fred's score above Adam's. And our last topic for the lesson is relative frequency. I'll have students take a moment to read the definition. When you read the definition, it seems like a mouthful, so let's just whittle it down to the basic parts. A ratio is simply a fraction. And so when we're comparing the two parts of the fraction, there's the number of times the event occurs, and we divide it by the total, which is very similar to what we had done in previous days as it relates to percents. So we're going to do a quick example here of relative frequency. They give out 5 $100 gift cards, 10 $50 ones, 35 $15 ones, and so on. So if we were trying to find the relative frequency, we would just take the amounts and divide by the total. We would need to find the total here, and real quickly we end up with 200. So we end up handing out 200 cards. So you would take each of these frequencies and divide by the total and turn it into a percent. Real quickly here for the weighted average, if students want to give that a try, the weighted average should be 11.375. And if they have questions about how to do that, they can ask.